So we'll start with a quick little review of stretches or compressions, and then we will look at combining all of the transformations we've learned so far. So we'll look at translations, reflections, and stretches all together. Okay, so the first question, 7 from homework, says describe the transformation that must be applied to the graph of f of x, so that's the blue curve, to obtain the graph of g of x. Then determine the equation of g of x. So that's the goal in this is to come up with an equation. Determine the equation of g of x. And it has to be in the form y equals a times f of bx. All right, it's in standard form. So again, we're just talking about vertical stretch or horizontal stretch. Now in this particular case, you can see these points didn't change, so that didn't really help you, but this point, 0, 2, became 0, 8. So negative 2, 0 remained negative 2, 0, 0, 2 became 0, 8, and 4, 0 remained unchanged. So it looks like nothing's happening to the x values, that's fair. What did I do to these y values to get these new y values? Okay, it's hard to tell with this one, but this one 2 to get an 8, I must have multiplied it by 4. Okay, so the mapping rule that would give me these new points on g of x would be x, 4 times y. So if it's the y values that are getting multiplied, we must be talking about a vertical stretch. Okay, so this would be a vertical stretch about the x-axis, so it's the opposite axis of what you should think. A vertical stretch about the x-axis by a factor of 4. That means my a value is actually a 4. Okay, there is no vertical reflection in the x-axis. So if a is a 4, I'm just going to write my equation like this. Y equals a, so I replace the a with a 4, f of, and there is no horizontal stretch here, so my equation would be y equals 4 times f of x. That's it. There is my equation. Now let's look at an example of one that has a horizontal stretch or compression. Okay, so the blue curve is f of x, that's the original. The red curve is g of x, that's the transformed. So look at these points, all right? It's clearly the x values that are changing. So if it's the x values that are changing, we're talking about a horizontal stretch or compression. Well, what did I do to a negative 6 to make it a negative 2? Or a negative, I had to do the same thing to a negative 3 to get a negative 1. A lot of people say, oh, you divided by 3. Okay, well, dividing by 3 is the same thing as multiplying by 1/3. Okay, so my horizontal stretch factor would be 1/3. 1/3 times x, and look at the y values didn't change. 4, 0, 4, 0, 4, 4, 0, 4, 0, 4. Okay, and I'm just picking those points off the red and blue curves. They were given in the picture. So for this, I would say a horizontal compression would be more appropriate here because the horizontal stretch factor is 1/3, or the horizontal compression factor is between 0 and 1. 1/3 is a fraction. Okay, between 0 and 1. So that it's more accurate to call it a compression. Horizontal compression about the y-axis. Remember, horizontal reflection and horizontal stretch are about the y-axis, and it's by a factor of 1/3. Okay, so if a was, vertical stretch factor was 4, a was 4. Horizontal stretch or compression factor 1/3, that tells me that b is equal to something. Now remember the relationship between the stretch factor and the horizontal stretch factor and your b value, they are reciprocal. So what's the reciprocal of 1/3? It would be 3, and it's this number that goes in the equation. So when I go to write the equation, my a value is just a 1. I don't even need to write it. f. My b value is a 3. times x. So there is my equation. If B is a 3, the horizontal compression factor would be 1/3. If B is a 1/3, my horizontal stretch factor would be 3. Okay, so there's a little review of stretches. Okay, now let's try and put this all together. All right, the parameters we've learned so far are A, B, H, and K. And your equation in standard form will look like this. A times F, open your bracket, B times X minus H, close the bracket twice, plus K. Vertical stretch or compression, if it's a negative, also vertical reflection, and those are in the x-axis. Horizontal stretch or compression, horizontal reflection as well if B is a negative. Okay? Just remember that the horizontal stretch factor is the reciprocal of this number. So if this is a 7, the horizontal stretch factor would be 1/7. If B is a 1/2, the horizontal stretch factor would be 2. H, horizontal translation, you have to remember to change the sign. So if this is a negative 3, x minus 3, it comes out as a positive 3, and you would translate 3 units right. It would get added to the x coordinates. K value is your vertical translation. A positive K value translate up, a negative K value translate down. You do not have to change the sign there. So our task here says given that negative 2, 5 is a point on the graph of y equals f of x, determine the coordinates of this point once the following transformations are applied. So we're transforming f of x 4 different times, and we got to make 4 different calculations for the point negative 2, 5. I took it one step further because I want you to get in the habit of verbalizing or describing the transformations. A lot of times the vocabulary in this first chapter is what throws students off. So please do your best to describe the transformations appropriately. So in this particular question, if I'm looking or I'm comparing this equation to this, well, I can see it's got an A value of 3. There is no B value, okay? So if there's no B value, it's understood to be a 1. B would equal a 1. So for this one, A is a 3, B is a 1. There's no H value in this bracket, so H would be a 0, and K, there's nothing out back. K is also a 0. So those are the parameters. Just remember that if A or B don't show up, they would get replaced with 1s. If H or K's don't show up, they would get replaced with 0s. Okay, I can't replace these with 0s because if it was 0 times that whole thing, you'd have nothing at y equals 0. It wouldn't transform anything. Okay, so just remember, A's and B's become 1s. If you can't see them, H's and K's become 0. So let's describe that. A equals 3. Okay, that would be a vertical stretch about the x-axis by a factor of 3. There would be no vertical reflection in the x-axis because A is a positive. So vertically stretched about the x-axis by a factor of 3. B is a 1. That means there's no horizontal reflection or there's no horizontal stretch. Okay? No horizontal stretch. H is a 0. Remember, that's horizontal translation. So there's no horizontal translation. And K is a 0. That means there's no vertical translation either. Here's how you would make the mapping rule. All right, x comma y is going to become, so it's 1 over b, all right, 1 over 1. I could write it like this if I wanted. What's that equal to, 1 over 1? Well, it's just 1, so I don't even need to write that, but I'll show you how to, just so that you can practice. X, and then I would add h plus 0. So remember, horizontal stretch or compression and horizontal translation, they are going to affect the x coordinates. And vertical stretch reflection, translation, they're going to affect the y. So it would be a times y plus k. So here's what the mapping rule is going to look like. X comma y maps to 1 over b times x plus h, and then comma a times y plus k. That's what we're going to be working with for the next several days and into chapter 2, 7, 8, and 5 as well. So rather than write 1 over 1 times x, a fella could write x comma 3y, same thing. 1 divided by 1 is 1, times x is just x, plus 0 is still x. 3 times y is 3y, plus 0 would be 3y. So remember, you're changing the point negative 2 comma 5, I believe. Not making that point up, it was given, negative 2 comma 5. So to transform it, all you have to do, nothing to the x values, multiply the y values by 3. So 3 times...
Mark, to the office, please.
3 times 5 would give me 15. So the point negative 2 comma 5 would become negative 2 comma 15. All right, if I carry on with this one, a would be a 1. Remember, there's no a, there's no number in front of the f, so a is a 1. B would be this value right here, which is negative 1/3. Okay. H, there's nothing after the x there, so h would be a 0, and k would be a 0. So pretty easy to describe the translations. No horizontal translation, no vertical translation. A stretch factor of 1 multiplying by 1 doesn't change anything, so you could say there is no vertical stretch factor. It's this one that's going to cause problems. Okay, so there is no vertical stretch factor. And since it's a positive, there's no vertical reflection in the x-axis either. The b value is negative 1/3. So that means there is a horizontal stretch factor of 3. Remember, you state it as an absolute value, and it's the reciprocal of this. And a horizontal stretch by a factor of 3 in the y-axis, and it would also be reflected horizontally in the y-axis. So let's read this. Take a minute to digest this. So b value is negative 1/3. That means it's horizontally stretched about the y-axis by a factor of 3. Remember, the stretch factor or the compression factor is always an absolute value, so I'm kind of ignoring that negative. What does the negative mean? The negative indicates that it's also horizontally reflected in the y-axis. And I can get rid of these two. We said there was no horizontal translation and no vertical translation. Okay, the mapping rule. X comma y. Remember, it's 1 over b. So if I write 1 divided by, my b value is negative 1/3. Okay, I'm not ignoring negatives here. Times x plus my h value of 0, comma, that is a 0. Comma, and then it's 1 times y, my a value is a 1, times y plus my k value is a 0. Now, think about what this means. What is 1 divided by negative 1/3? Well, when you divide by a fraction, you just multiply by the reciprocal of that. Well, the reciprocal of negative 1/3 would be negative 3, so I'd get negative 3. This right here would simplify to a negative 3. So I'll have negative 3x plus 0 is just negative 3x, and 1 times y is y. So that is my mapping rule. I'm going to take the point negative 2 comma 5. I am going to multiply the x coordinate that's negative 2 by negative 3. That would give me positive 6, and I'm not doing anything to the y value. Okay, there is my new point. All right, here's my A, Here's my B, here's my H, and here's the K. A is 4. What does that mean, folks? It means it is vertically stretched about the x-axis by a factor of 4. No vertical reflection in the x-axis because this is a positive. B is 1/2. Okay, so I'll say that B is 1/2. There it is. I write my B value as 1/2. But it's horizontally stretched about the y-axis by a factor of 2. I use the reciprocal. That is the number, that 2 would be the number that goes in my mapping. My H value is a +5 in the brackets. It comes out as a -5. So it's translated 5 units left. Okay? And my K value is -3. So to be vertically translated 3 units down. So just so you can see all of that. A is 4, vertically stretched about the x-axis by a factor of 4. My B value is 1/2, stretched about the y-axis by a factor of, horizontally stretched about the y-axis by a factor of 2. H is -5, that's translated 5 units left. And K is -3, that's translated 3 units down. My mapping rule would look like this. X comma y would become, the horizontal stretch factor was 2, so it would be 2 times x. If you're wondering where that 2 comes from, if you went 1 divided by 1/2, that equals 2. 1 times the reciprocal of 1/2 would be 2, so 1 times 2 would be 2. And then I'm going to add -5 or subtract 5, comma. My A value was a 4, so it's 4 times y minus 3. So the point -2, comma, +5 would become 2 times -2 is -4. Okay, minus 5 would be -9. And 4 times 5 would be 20. 20 minus 3 would be 17. Let's just see if I did those correctly. A is 4. B is 2. Sorry, B is 1/2, so the horizontal stretch factor is 2. -5 and 3. Yep. Okay. The last one, we have to go y equals -2f, and this would be -2x plus 6 in here. Be a +5 back here. One extra step. I am going to factor in these brackets here. I'll factor out a -2. To factor it out means to divide both of these terms by -2. So -2x divided by -2 is x. +6 divided by -2 is -3. And now you can see A is -2. That means there is vertical reflection in the x-axis. B is -2. That means there is horizontal reflection in the y-axis. H would be a 3, and K would be a 5. So you're going to go 3 units to the right and 5 units up. Here's how you describe the transformations. A is -2. Watch this. 2 things. Vertically stretched about the x-axis by a factor of +2. Okay. And reflected in the x-axis, and vertically reflected in the x-axis. B is -2. That means it's horizontally stretched about the y-axis by a factor of 1/2. I'll just delete this stuff. So it is horizontally stretched. Looks like I deleted some. About the y-axis by a factor of 1/2, and it's reflected in the y-axis. Why is it reflected in the y-axis? Because it's a negative. Why is it reflected in the x-axis? Because A is a negative. So the only time you have to say reflected in the x-axis if your a value is a negative. The only time you have to say reflected in the y-axis if your b value is a negative. It went 3 units right. Remember, when you take this out of the brackets, you change its sign. And 5 units up. So I would have x comma y would become, so 1 over b, that would be 1 over negative 2, so negative 1/2 times x plus 3, and then a times y, my a value is negative 2, negative 2 times y plus 5. And the point negative 2 comma 5. What's going to happen to it? What is negative 2 times negative 1/2? That would be positive 1 plus 3. That would give me 4. 5 times negative 2 would be negative 10. So if I plug the 5 in there, negative 2 5s, or times 5 would be negative 10. Plus 5, I'd get negative 5. Okay. So I encourage you to have a look at all of this. Right, I know it's hard to read, so maybe go into your Teams app and look at the notes. But I want you to get into the habit of describing the transformations so that you can do this, okay? I want you to just fill in the blanks. So take this equation, put it in standard form by factoring. Pick out your A value, B value, H value, and K value, and then fill in the blanks. So there is your homework. So if you think A should be about the x-axis or about the y-axis, you got to give me x-axis or y-axis by a factor of, tell me the factor. Vertically stretched about the x-axis or y-axis, tell me the factor. Is it reflected in the x-axis or is it reflected in the y-axis? Tell me. And then translate it blank units to the right and blank units down. So first thing you need to do is factor that 4 out, just like I did in this example right here. Okay, I factored here. Best of luck.